Okay, welcome back. And now what we're going to do is we're going to talk about one of the most important theorems in calculus, and that's the mean value theorem. The mean value theorem is used quite a bit, and like I said, it's one of the most important theorems that we're going to use and discuss in calculus. Now, before we start talking about the mean value theorem, and we'll get into applications or uses or what should I say, not applications, but I guess aspects of the mean value theorem later on. But right now, before we get into the mean value theorem, let's discuss a special case of the mean value theorem, which is Rolle's theorem. Now, what Rolle's theorem is basically says, and I'll read to you the theorem in a moment, but what it says is that if we have a differentiable function where the value of that function is the same at the endpoints, then there must be some point, some c value, some point inside the interval such that the derivative of the function at that point is 0. Okay? Think about it. If I have a function here and a function here, let's say they're equal at the endpoints, so the function may do something like this, something funky, or maybe do this, or maybe a straight line. Okay? But in any case, because since it starts here and does something funky in the middle, right? And then it ends at the same height of the function. Think of height, right? Then no matter what's going on here, there has to be at least one point in the interval where the derivative of the function is 0. Why? Because it had to change direction at least once. Or even if it didn't change direction, you're still right a horizontal line, right? And then that would mean every single point, right? But the theorem's saying at least one, right? So if it's going up and down, there's got to be, even if it starts up and it goes down, so there's got to be at least one point where the graph changed direction, and of course if it changes direction, then that means there's got to be either a maximum or a minimum. And of course, what kind of tangential line do we have when it's a minimum or maximum? It's going to be horizontal. Okay? And what's the derivative of any horizontal line? 0. So that's where Rolle's theorem comes in. So what does Rolle's theorem say? Okay, so here's the formal theorem. It says, let f be a continuous function over the closed interval ab, and differentiable over the open interval ab. Okay, now why continuous over the closed and differentiable over the open interval? Well, that has to deal with the fact that as long as it's continuous, if it's differentiable, then we know it's continuous over the open interval, right? So that automatically gives us continuous. And continuous over the closed interval, so that way, as far as looking at the endpoints here, a, b. And as far as differentiable, we can always find the limit as we approach b from the left or a from the right. Okay? So, as long as f is a continuous function over the closed interval and differentiable function over the open interval ab, and such that f of a is equal to f of b, if this is true, then there must exist at least one c in the open interval ab, such that f prime of c is equal to 0. Okay? So there must be at least one interior point such that f prime of c is equal to 0. That's what Rolle's theorem states. Okay, now this again, as you'll see, this is just a special case of the mean value theorem that we're going to get to later. Okay? Have a great day.